In this video, we are going to look at how to delete the initial node from a singly linked list. So here we have a simple singly linked list with only 2 nodes in it, because that's going to be helpful for illustration when we see the last node deleted. And we're going to look at how to delete the beginning node, and we're actually going to do that twice so as to make the list empty. So the operation is fairly simple. We just have to be careful to not lose pointers to anything that we need. So let's suppose that we're going to delete the beginning node, and like in the stack example in the book, we are going to return that beginning node to someone rather than simply make it go away. And indeed, that's the common case. Okay, so we want to take this node out of the list. So what we do is, first of all, we save a pointer to this node so that we can change front to point to this node and still have some way to get to this one. So save a pointer to this first node, and then we copy the next pointer from this first node because it tells us how to get to the rest of the list. We copy that pointer to front here. So front, so this gets copied to front, so front becomes a pointer like this, which means, of course, its old value no longer exists. And now we have a list with a single node in it, or one fewer nodes than there were before. And we also have the save pointer that points at what used to be the first node so that we can send it off somewhere. So let's suppose that we did that. And now we're down to a list with a single node. And now they ask us to delete the beginning node again. So we do the same thing as before. Even though there's only one node in the list, the right thing will happen by following the same process. So we save that initial node, which is the initial node now, it's the only node. And then we copy the next pointer, which, sorry, should have been like that to show that it was null. We copy that next pointer from that saved node to front. And so front becomes a null pointer, which I'm going to draw like that. So again, that means the old value of front no longer exists because a variable value changes permanently when it is changed. The old value goes away, and now we have this save node that we can give to someone, for example, again in the stack ADT, and front now points at null, meaning that we have an empty list. And of course, if we're keeping a counter of the number of items in the list, so that we don't have to traverse it to see how many items are in it, we need to decrement the counter each time we do that delete the initial node.